I am going to teach you the polarization of EM wave. As in previous videos, I have already discussed that to develop any concept, you must have to go through previous year problem, and in between solving that problem, you go through the standard books, clear the concept, and in this way you can develop a concept that is going to be very useful for GATE exam. So I have taken in the same way and taken a problem from the previous year, and the question can be read as the electric field of a uniform plane EM wave in free space along the positive x direction is given by vector E equals to 10 vector AY plus J vector AZ exponential minus J25x. Okay, this is the equation of the electric field. And the two things that we have to discuss here, the frequency we have to find and the polarization of the wave. We have to decide what is the polarization, and the options are here. This part is the frequency and this part is the type of polarization. So one by one I will discuss both the topics. First, the frequency. So in plane wave, for a plane wave traveling in positive x direction, the generalized form of the equation in phasor form. It is written as vector E naught, of course this part is vector as well, exponential minus j beta x. From here we can decide if here x, then the direction of the wave is in positive x direction, as here we can see positive x direction. If here it will be z, it will be in positive z direction plus j beta x. If here it will be plus j beta x, then the direction will be in negative x direction. And if it is a mixture of two, whatever it is, we have to find out, just find out the gradient of this part. Means if I put here r, some r term, not x, instead of x there is r, then we can find out the direction by gradient, taking gradient of r. Okay, so here it is x, so vector ax will be the direction of electric field. Now the same thing can be written in the time domain as E naught cos omega t minus beta x. In time domain it can be written as this. So what we have in the question, vector E equals to 10 vector ay plus j vector az. This part is important for finding out the frequency. Only this part, exponential minus J25x, means the wave is traveling in positive x direction, and this is the value 25 is the value of beta. Here we can see this is beta. Beta is what? Beta is the phase constant. Beta is phase constant. And there is a wonderful relation in between beta and frequency of the signal, or you can say EM wave, electric field component and magnetic field component. There is frequency omega, and Vp is the velocity of wave in that medium. Okay, and here the medium is free space, so velocity of the wave will be similar to the light, because EM wave has the property of light, so it travels in with the same speed, and the speed of light is 3 into 10 raised to 8 per meter per second. So we put beta equals to 25 from here, and Vp equals to 3 into 10 raised to 8 from here. So we can find out easily omega this and frequency this. So frequency can be easily find out. So half part of the question has been done here, and now I come to the next part, that is the type of polarization. So for finding out type of polarization, we must understand what polarization actually means. Polarization is nothing but the direction of electric field of the EM wave. So if any equation is written in this form, EY vector, means there is a vector AY component of electric field and vector AZ component, and both the components are in phase. We can see here that EY is some constant and EZ is constant. For example, 2 vector AX plus 3 vector AY, and rest is the same, exponential minus j beta x. So this type of polarization will be called linear polarization. Now the question is why? Actually this is in phasor form. When we write it in time domain form, so how we can write it? Vector E, Ey vector Ay plus Ez vector Az cos omega t minus beta x. So here we can see that electric field is written now with time. When I change time from 0 to some value, time is increased. So with increasing time, what the value of electric field is. So we can see here the value of electric field will change according to this value, but the direction of electric field will be constant, as this is always constant independent of time. It doesn't depend on time. Okay, so this part is constant, means direction of electric field is independent of the time. And when the direction of the field is independent of the time, then of course that if I find out that its direction somewhere here, so the magnitude can vary, but the direction will be the same. So we can see that the polarization means electric field travels on a line, so it is called linear polarization. So from here it is clear how this form of equation is linear polarization. So point to be noted that when both the components are in the same phase, means they are constant values, there is no any difference in the phase, then it will be linearly polarized. Now come to the second type of polarization, or you can say two mixed polarization. Elliptical it may be, or it may be circular. When it will be elliptical and when it will be circular, let us see. This is the form of elliptical or circular polarization. Here we can see that there is a phase difference of just 90 degree, or either plus 90 or minus 90, means this can be lead or can lag. Okay, but when there is a phase difference of 90 degree, then in that case the polarization will be either elliptical or circular. Now when elliptical and when circular, when the two components, these two components, means Ey will be exactly equal to Ez, means its magnitude. Of course this is constant terms. These magnitudes are equal, then we will say that this is circular polarization. Circular polarization. When Ey will be not equal to Ez, then it will be elliptical polarization. So we have already understood that the type of polarization means circular and elliptical we can easily detect by checking these constants, whether these two constants are equal or unequal. So here in the given question we can easily detect that the two components, of course vector Ay 10 and here also 10, so the two components, the magnitudes are equal, so this is circular. Now come to the left hand circular or right hand circular. So this is an important part. So when it will be left circular and when it will be right circular. Now again we can write the equation as Ey vector Ay plus, I am taking plus j at once, and at second attempt I am taking it E naught both, E naught means constant, means I am taking only circular case. Similar will be elliptical case as well. I am taking only circular case. E naught vector Ay plus j E naught vector Az, means this part, the z component leads. Here of course we will have exponential minus j beta x. So this part will lead. So what we get, that if I plot here, this is x component, this is y component, this is z component. So E naught vector Ay, this in this side there will be a vector electric field component, in this direction there will be an electric field component, but the z direction electric field component leads, means what, at initial time first the z component will come, means this component will lead, and of course at that time this component will be very less, so overall resultant electric field will be towards this. When the time passes, again this leads, means after some time this part will decrease, this part will dominate and this part will, means we can say that in this way we write it in cos omega t, so we know very well that in this way something part will come, means this is first the z part comes, this is z part, and then ey part. So what we can say that initially there will be a larger z component, and when time goes on there will be a larger y component. So the tip of the electric field will follow this path, means initially it will be towards z, when time goes this part decreases and this part increases, so on, and here it comes. So what we can see, the direction of the tip of electric field, resultant electric field, travels this way, okay, and the direction of the EM wave is x-axis. So for this direction, when we put our left hand, the direction will be upward, means direction will be this way. So what we can say that this follows the left hand circular polarization. So what we can say that this is the type of left hand circular polarization, but when instead of plus here we will have minus, means this part will lag. So first the y component will come and then z component will come. So the the tip of the electric field will travel this direction, the opposite direction, this direction it will travel. So in that case we will have to put our right hand to show the EM wave direction, that is vector AX. So that will follow right hand polarization. So when it will lag, there will be right hand polarization. When it leads, there will be left hand polarization. So this is the difference between left hand and right hand polarization. Now for the given question, given problem, as we have this part leads, so what we can say that this is left hand polarization, as we have already discussed that this is left hand polarization. So left circular and 1.2 gigahertz, this is the correct answer. Thank you so much. I will come with some other videos in the coming days. Thank you.